Hello, and welcome to this presentation, Getting Started with the EVS1000 ILS Glidepath Mode. In this presentation, we'll show you how to make measurements of ILS Glidepath signals using Rohde and Schwarz EVS1000 series analyzers. This presentation assumes a basic familiarity with ILS signals and Rohde and Schwarz EVS1000 series analyzers. If you're unfamiliar with either of these topics, or if you'd like a review, you might want to watch the presentation Understanding ILS and/or Getting Started with the EVS1000 General Overview before continuing with this presentation. ILS Glidepath analysis is enabled by Software Option K1 and provides a wide variety of measurements of glide path signals. These measurements include various modulation depth measurements, individual and combined measurements of course and clearance, and various distortion and harmonics measurements. Measurement data can also be recorded for viewing on the EVS1000, or can be exported for external analysis. To access ILS Glidepath analysis mode on the EVS G1000, simply press the Mode hard key on the front of the instrument and select ILS Glidepath. If operating the EVS over VNC, press M, and then use the down arrow to scroll through the list of available analysis modes. The first step in ILS Glidepath analysis is entering the frequency or channel of the ILS Glidepath signal. This can be done either as the absolute frequency in megahertz or as an ICAO channel number. Note that the EVS will automatically calculate and display the corresponding value. To change the frequency or channel on the EVS G, press the Channel Frequency hard key. In VNC mode, use the keyboard shortcut Q to enter either frequency or channel. The EVS also provides an easy way to switch between Glidepath and Localizer modes. Pressing the ILS Localizer key switches the EVS to Localizer mode. The Localizer frequency is automatically configured based on the paired Glidepath frequency. In this example, ICAO channel number 32X corresponds to a glide path frequency of 332.6 MHz and a localizer frequency of 109.5 MHz. The ILS glide path key can then be used to switch back to glide path mode and revert back to the paired glide path frequency. ILS glide path measurements are divided into 4 different views on the EVS. These are main, course and clearance, distortion, and recording. We'll start by looking at the main analysis view. The main ILS Glidepath analysis view is divided into 3 sections: the level and frequency display, which provides information on the power and frequency of the received signal, the IF spectrum view, which shows power as a function of frequency, and the main numerical results, which can be figured to show various measurements and parameters of the received signal. As mentioned a moment ago, the level and frequency display shows the power and frequency of the input signal, with power shown as an absolute value in dBm, and frequency shown as an offset in Hertz from the nominal or configured glide path frequency. The bar graph shows the overload state. Green means no overload, yellow indicates an approaching overload, and red indicates that overload is occurring. Note that in course and clearance modes, separate bar graphs are displayed for each signal. If an overload condition does occur, different messages will appear depending on the type of overload. For example, here both RF and ADC overloads. Regardless of the cause of the overload, the solution is to reduce or attenuate the input level, and this can be done by setting RF attenuation to either normal or low distortion. Please see the EVS1000 General Overview presentation for more details on configuring RF attenuation. The IF spectrum preview provides a plot of power versus frequency, similar to a spectrum analyzer display. The center of the display, or the zero frequency, is the nominal channel frequency, and the frequency range, or span, is set to the measured bandwidth. The EVS chooses a power range that will display both a peak and noise simultaneously. The main application of the IF spectrum preview is verifying the measurement settings are appropriate. For example, we can use the IF spectrum to see if a glide path signal is present, or if there's noise or other types of interference in addition to the glide path signal. although the EVS automatically chooses the frequency range or span to be used based on the nav aid type, RF spectrum mode can be used to choose a larger span if needed. This is covered in a separate presentation. Note that if RF spectrum mode is chosen, the current settings, such as channel frequency, are transferred to that mode. The Glidepath numerical results view indicates difference of depth of modulation and sum of depth of modulation for the 90 and 150 Hz Glidepath signals. Green is used to indicate a valid DDM signal, and DDM is also displayed as a bar graph. The AM modulation depths and frequencies of the 90 and 150 Hz lobes are displayed in addition to the phase angle between them. Many ILS systems consist of both a coarse and a clearance signal. A single receiver board on the EVS1000 can detect, measure, and display coarse and clearance signals simultaneously. The way in which the EVS displays the measurement results depends on the channel configuration. That is, whether the EVS is configured to measure at 1 or 2 frequencies. To configure channels, press Measure and then 1F, 2F, or use the VNC shortcuts M, F1. Here we define whether we're making single frequency or dual frequency measurements. 1F measures only at a single frequency, whereas 2F measures at 2 frequencies at the same time, and results are reported as the sum of both measurements. It's also possible to perform a dual frequency measurement where results are reported either for coarse or for clearance. And finally, there's a wide mode that measures over a wider bandwidth. This can be used to look at both single or dual frequency glide path signals. In coarse and clearance systems, each component is offset from the nominal glide path frequency. Autotune can be used to automatically determine the frequencies of each signal component in 2-channel configurations. When enabled, Autotune will go through 3 steps. It first searches for signal peaks within the measurement bandwidth. It checks these peaks to see if they are ILS signals, and if so, it then locks onto these frequencies. The status of Autotune for each carrier can be seen just below the frequency display. Autotune will automatically attempt to find the carriers, but this process can be restarted by using Find Carrier. Signals must also be above the defined carrier threshold level, in dB, to be detected. And upper frequency specifies whether the higher frequency carrier is the coarse signal or the clearance signal. This can vary between standards and in different parts of the world. Autotune for coarse and clearance is enabled by default, but it can be disabled by changing the coarse clearance carrier setting from auto to manual. In this case, the offsets for coarse and clearance must be manually specified. Here, the coarse signal is 10 kHz above, and the clearance signal is 5 kHz below the nominal glide slope frequency. The glide path distortion view shows the distortion factors for the 90 and 150 Hz signal components. These include the AM modulation depths for each lobe, the harmonic distortion for the second, third, and fourth harmonics, and the total harmonic distortion, as well as any residual frequency modulation. The parameter AM90 plus 150 refers to the combined AM modulation depth of both lobes, taking into account the phase difference between them. The last view we'll look at is the recording view, which displays and stores ILS glide path measurement data in tabular format. If GPS data is available, this data is also stored with the glide path measurement data. Please see the separate presentation, Getting Started with the EVS1000 Data Recording, for more details and step-by-step instructions on logging and exporting measured data. In this presentation, we've covered ILS glide path analysis mode, which is enabled by software option K1. This option performs a wide range of measurements on glide path signals, including difference and sum of depth of modulation, modulation parameters on both the 90 and 150 Hz lobes, and distortion measurements. These measurements can be performed for coarse, clearance, or both, either individually or simultaneously. Additional displays of the received signal level and frequency, as well as a spectrum view, can be used to verify the presence of the glide slope signal and/or the presence of other signals or noise. All measurement data can be logged together with GPS time and position information. And finally, configuration of glide slope analysis is very easy. Simply enter the ILS frequency, either in megahertz or as a standard ICAO channel number, and specify the channel configuration. This concludes our presentation, Getting Started with the EVS1000 ILS Glidepath mode. If you'd like to learn more about the EVS1000 or other avionics-related topics, please see the links in the video description. Thanks for watching.